And I'm at the whale end of the spectrum. I'm one of the big boys, if you like. And my interests, like many other people in the Scottish Ocean Institute, lie at this boundary between the natural world and the human world. And we're trying to understand how those two interact. And it's illustrated quite well here with the dolphin sitting on the bow of a large supertanker. Many of us would look at this and think, well, the dolphin's managing quite well, actually, in front of all this. But actually, one of the things that we're interested in is the dolphins that aren't there, the ones that are scared before the supertanker ever gets over the horizon. And I just want to illustrate this from the animal that's actually illustrated on the top of this slide, which is actually a beaked whale. These are extraordinarily sensitive animals. There's 21 species in the world, we think. We think there may be other ones, and we're discovering a new species about once every 10 years of these whales. They're the size of a rhinoceros, and there's quite a lot of them just off the British coast, and we don't know they're there. So that's how timid these animals actually are. And we're trying to study these animals and understand more about their lives, because they are affected quite badly by sonars. And these sonars, one of which is about to play now, that's a US Navy anti-submarine sonar. That's the sound they use for hunting for submarines. And unfortunately, US anti-submarine sonars actually kill these animals in certain circumstances. And the job that we did was to try and find out what the circumstances were, to be able to advise the US Navy and NATO and the Royal Navy about how not to use the sonars in certain circumstances in order to be able to avoid putting these animals on the beach. This, by the way, is a sonogram showing the echolocation clicks. I'm going to try and play it again. And each of these clicks is the animal looking for a prey item. And the buzz that you hear is the animal, when it's found a prey item, zeroing in on it. The important thing about this I want to illustrate is that this is measured from a small electronic tag that we attach to the back of the whale. And it's measured on a whale that's about 1,500 meters below the surface in the Bahamas. And because of technology that we developed in St Andrews, we're able to do these sorts of things. We're able to actually see the world as these animals see it. And we're able to see these echolocation clicks bouncing off the prey items that these animals are actually hunting down. Another illustration of the kind of thing that we do is to track elephant seals in the Antarctic. This shows the movement of animals moving out of their breeding areas around the Antarctic. Why do we do this? We do it because we're able to put these instruments on animals that allow us to be able to measure the quality of the water column. And when the animal comes back to the surface, the information is transmitted straight back to us in our laboratory, and we pass it straight on to the Met Office, which then incorporates it within weather forecasting models. So we have animals like elephant seals, one of them illustrated here, collecting data for us, which we're using in real time in the real environment. This interface between man and the environment is brought into stark illustration by what's happening immediately offshore from Scotland and from the rest of the UK as well. We have a huge resource in our oceans. We've got an immense amount of oil and gas. We transport most of our raw materials on the oceans. We exploit the ocean seabed for gravel, and we also exploit fish as well. So it's an important food resource as well. But we all know that it's also an important place for developing renewable energy, which is vital to our future. One of the problems with renewable energy is that it is going to have environmental impacts. And one of the tasks that we have as scientists is to advise industry and government about how best to develop renewable energy in a way that is going to minimise those types of impacts. We need renewable energy, but we don't want renewable energy to have negative impacts, and it could, particularly on things like marine mammals. Illustrated here is a tidal turbine that is in Strangford Lough Narrows in Northern Ireland. We did all the environmental impact assessments around that and the management process around this installation of the turbine, because it's in an area of special scientific interest for seals. And there's a lot of concern that these turbines might actually damage the animals, and the animals go through the turbines. So we've been able to show and manage, show that that doesn't happen, and also manage the process associated with installation. That's all extremely important, and we think that we can reduce the risk to the environment through sensible management of these processes, through the advice we're able to give by up to 80 to 90%, depending on the circumstances, and certainly that's our experience with fisheries. But I just want to finish now by saying that actually from a personal point of view, working in St Andrews is hugely rewarding. It's not just St Andrews, but the subject area that we work in is fantastically stimulating. We have a highly motivated scientific staff who work all over the globe and bring back this information, use it and process it in such a way that students can understand it, so that we can then develop a new generation of scientists who, in their various ways, not all of them will want to research, but in their various ways and various walks of life, will take the general message that we're giving away with them. So with that, I'll thank you for your attention, and I'll be happy to answer any questions later on. Thank you very much.